The following diagram demonstrates the capabilities of F5 Distributed Cloud to infuse flexibility into context-enriched RAG. In this case, we'll run an LLM in our Redmond, Washington location. We'll then begin to ingest through embedding LLM remote data stores around the world in public clouds like Azure and AWS, as well as corporate sites. In our example, we'll ingest data from an appliance of NetApp in a San Jose office. The key to understanding the value proposition is that these connections can be made at layer 3 through multi-cloud networking network connect. Layer 3 connectivity is provided by the distributed cloud, or we can provide a load balancer based L4 to 7 solution where load balancers project protocols like S3 over HTTPS, or TCP load balancers provide access to NFS or SMB volumes. In the following brief example, AppConnect was selected. It will set up an HTTPS load balancer which will project access to the hosted LLM in Redmond, Washington to files and folders that are located on a NetApp appliance in San Jose. This is what infuses RAG with its ability to do context-aware AI inferencing, the ability to parse our own data and provide that data as the catalyst for meaningful answers. In this demonstration, we've selected AppConnect, meaning load balancers and projecting services from one location to another. In this case, we've created a load balancer, S3 content HTTPS load balancer, to take data ingested in San Jose, California, and project availability to it using the S3 protocol to LLMs that are located in Redmond, Washington. The key details are the name of the service. A fully qualified domain name compliant for internet purposes is possible. In our case, we'll use a private DNS compliant name. The service will be supported using HTTPS with a private certificate. Again, if projected to the general internet, Distributed Cloud will mint a publicly trusted certificate for your application. The port in use will be 443. Key deliverable is what is being projected. It's located in San Jose. And essentially what we have is a private address, so a 10.xxx address sitting behind a San Jose secure mesh site 2CE. It will talk locally on port 443. And there'll be a series of health checks ensuring availability of the appliance. With this done, we can add web application firewall features. We can also add API protection. So S3 is an API-centric protocol, very useful to do. The last thing to note is where will this service be made available? This is completely under the purview of the Distributed Cloud Administrator. This will not be available on our RE network to the general internet. It will only be available in Redmond on the inside interface of the CE that's in the Redmond location. Whether we use layer 3 network connect or load balancers and AppConnect, regardless, we could mount traffic which resides remotely, locally in the Redmond office by using an NFS mount command for the NFS protocol. Similar mount commands exist for protocols like S3. At this point, in a self-hosted LLM environment, we can simply use a utility like Olama, where we have an embedding LLM by Nomic, and we have a choice of 3 different generative LLMs. An alternative would be to use Hugging Face and similarly load embedding and generative LLMs. This is a host in the Redmond location. This demonstrates that Distributed Cloud AppConnect has made available through the S3 protocol various folders in the San Jose office, any of which can be used as RAG material in the sense that we will be able to ingest these files as embeddings and put those embeddings into a vector database. Any queries can semantically be compared to content in any of these files to produce the optimal answer from the LLM. The following example demonstrates the power of context with a RAG solution. A very nebulous question without great detail is offered to the LLM. Due to RAG, it's able to find, and through semantic similarity with the vector database, meaningful data related to our question is provided to the LLM, thereby producing this meaningful answer. Beyond this, we also see attribution, the actual sources, what documents, what pages, and what chunks on those pages led to the answer. In summary, RAG adds context to AI inferencing. RAG requires access, though, to disparate sites in the enterprise worldwide, wherever they exist. F5 Distributed Cloud allows easy access to files, things like SMB shares, NFS volumes, and S3 buckets. A worldwide high bandwidth RE network is available to transport intersite connections. Between your sites, Distributed Cloud offers two technologies which can be mixed in many cases. One is a layer 3 IP reachability solution called NetApp. Essentially, sites on the inside interfaces can talk to other sites' inside interfaces or inside VLANs. The other approach is a traditional L4-7 load balancer service where origin pool members are projected to very specific consumer sites in your organization. Thank you.